In today's video, we will discuss your first project in FIFO Testbench, and the project is about FIFO. If you are able to do the FIFO code with design and verification, then it is easier for you to design any protocol code. So watch this full video for complete verification of FIFO and for future projects in protocols. So first I will explain you the design. I have not coded the design in front of you because it will take time. So let's go with our design. So you need to remember that FIFO is a container. First come first out means whenever you enter the data first, it will come out first. So for that we have declared one internal memory which is not in the port. So this is your memory space. Second, we have declared FIFO count because we want to know which memory location is full or which memory location is empty. And whole code of FIFO is about your memory locations where the pointer is, and we will only check that if FIFO is full, then we cannot add the data, and if FIFO is empty, then we can add the data. But in empty condition we will see how to read the data. Okay, so these are the necessary signals for that: read and write, clock for our synchronization, reset is asynchronous. And let's see what is our code. So FIFO empty condition is when FIFO is count equal to 0, and FIFO full condition is when FIFO count is 7. So simple. So at every edge triggered process, we will see that if FIFO is not full, then only we can write. Okay, and second condition is FIFO is not empty, then we can read. So if that happens, we will just we will increase our count. Counter increment, or we can say pointer increment, or functionality of FIFO. So not full, write the data but not read, means here only we are writing the data. So what happens, our counter will increase. And if FIFO is not full and we are not writing the data but we are reading the data, means we have read one location, then we will minus 1 count from here. Otherwise FIFO count equal to FIFO count, means whatever count is we will consider. Now here we will enter our data. Here whole conditions of pointer is completed. Whenever there is the full data, whenever there is empty data, we will get to know. Now always process of clock or process of reset, means whenever there is reset, we will just do our location empty, means data out equal to 0. So if reset is there, we will do data 0. Otherwise if write condition is there, then we will enter our data. If read condition is there, then we will read the data. Otherwise data out equal to 0. So this is a simple code for FIFO. So in this video I haven't created any architecture for Testbench, but you can create your own architecture. Component will be same. So first is our TB top. In that we will just include our design, our program block, and our interface. In this video I have included program block. So let's see after the TB top, the instantiation for interface, instantiation for our design, and instantiation for our TB top, means program block. And second, our most important thing is clock generation and reset, which is the global signal. Therefore we will do it in our TB top, means architecture top module. Second is our program block, which we used for, because we don't want any timing errors. You can study this. This is in dynamic nature. This region of execution is a reactive region. So we will just include our package where all our data classes is there, means our every class is there. So include packet, configuration, scoreboard, coverage, every class is here. So listen carefully here. You have to do your instantiation like whatever class is building first to last. So for example, test is building first, so we will write the at bottom, then our environment, then our generator, then our driver, then our monitor, and rest of the things are your classes like packet, your configuration class, which is throughout the module, means objects. In UVM language we can say it's objects, which is created at runtime and destroyed at runtime. So these two are like this, and other things are your building blocks. First is build, then environment, then generator. You can also look it like a connection. For example, first there will be a packet generation, then there will be configuration, then there will be scoreboard, coverage, and as per that your whole thing is building. Now this is our package class. Then other things are, we will just include our test class and configuration class here, and we will create our configuration and we will just run our test. Rest of the thing is like building test, connect test and run test class. Similar for test class, we will here include environment configuration, create this configuration, pass this configuration, and just build environment, connect environment and run environment. And here we are also running our generator class, and for every class we will create its own memory. New is for memory. Configuration class, we will include all the mailbox and pass this to our whole testbench architecture. Packet is our read write, whichever packet you want to generate, which will be generated in our generator class. And in generator class, this mailbox is come from our configuration class, which will be created in generator. Here we have given the memory for generator. Configuration class, we will configure the generator with generator mailbox with our configuration mailbox, and here we will write the data 500 times and creating our packet. Packet is our packet class packet, giving memory to our packet, randomize that memory, and we will just generate that data and send this data with the mailbox to our driver. Then this driver class will take this with our configuration mailbox, which is our generator mailbox, and we have also used our virtual interface, which is inside our configuration class. Is this interface as a working as a pointer to our real interface. This interface, we will use this interface to send our data from generator to driver and driver to this interface. So here this line indicates that first we will take the data from our generator class, means packet from our generator class, and then we will send this packet.write to our interface.write, means to our interface. After entering to the interface, I will show you interface first. See, this is our interface, all the signals are here, global signals are also here. Then interface, we will just see our input monitor. So these are the mailbox. These mailbox are also written in our configuration class, which is passed to our new constructor. In every testbench class, this we will create one memory for that, because we will send this mailbox to our scoreboard. So similar for coverage also, but in this video also I will not cover coverage, because coverage is totally separate topic. Now, as our packet, we will also include one variable for packet, because to recognize that previous is also our packet. So this new packet, we will give it to a memory, and this interface will give the data in, and which will be inside our packet.data in, means whichever data is sent to our interface, we will get this from our packet. So here it is, I am showing the flow of testbench, but where the duty is here. So whenever there is interface which is connected to our duty, so this interface will send data to our duty and it will process that data. Then this data will be inside our interface again, and then we will get this data to our input monitor. So don't forget this. I am telling you about testbench here, so I will only tell you about testbench flow. But after interface, it goes to our duty, means FIFO, then it comes again to our interface. Now, similar for output interface, output monitor also, nothing new like input monitor, but you have to also see that every passage of clock, it is receiving the data. Similar for our driver also, driver. Yes, forever begin, but every passage of clock, it is sending the data. Similar for input monitor, every passage of clock, it will get the data. Forever begin are used in both the classes. Now we will see our scoreboard. The input monitor and output monitor mailbox will be included in our configuration class, which will be used, and two packets I am using for comparing that data. Configuration class we will pass throughout our environment, and we will here there is no need for the build function, because it is the last class. After that, if there is another scoreboard including this scoreboard, then we will use this build, otherwise we will not use this build. So in generator, driver, scoreboard, we will not use this build, but I have written this because if there is another class after scoreboard, then we will use this build. So connections are, we are connecting our configuration mailbox to our this mailbox, and we will get these two packets from our input and output mailbox from our monitor. Then we will compare that packet 1 data to packet 2 data, means before processing the data in and after processing data out from our output mailbox, from our output monitor. So if the data is equal to data in, means our working of FIFO, that first data is equal to first data out, then it will say pass process, means increment our pass counter. And here we have used static keyword for pass and fail because our SV class or any class in any language work as a dynamic in nature, so we will give it as a static behavior because it should create that memory and overwrite that memory, not creating new memory. So count should be increased, and we will display that, and also our fail count, and display both the count. So this is whole our testbench architecture, simple architecture, good for your first project. And if you need any other project like FIFO, you can comment me. Thank you.